Hi guys, welcome back to In Case of Econ Struggles. Today we're continuing to talk about central bank behavior and loss functions, but today we're talking about unobserved shocks. Timestamps are below if you would like to jump around, but let's get right into it by talking about this loss function. Now this loss function is going to look a little different than we've seen previously because we have unobserved shocks, so we don't know what our loss is going to be today because we haven't yet seen the shocks when we set our interest rate. So we're going to have the expected value of the loss, or ET, of our normal loss function, where again our y star is 0 and our pi star is 0. Now because we're dealing with expectations, we're going to need a couple expectation tricks to help us solve this problem. So for context, we have this rule which says that e of x squared is equal to the expected value of x quantity squared plus the variance of that value x. So if we're thinking about the shocks to the IS curve as an example, the expected value of those squared shocks is just the expected value of the shock quantity squared plus the variance or sigma squared of the IS shocks. And both of the shocks, the IS shocks and the LM shocks, are mean 0 IID normal, so a mean of 0 and a variance of 1. Once again, we're going to plug this loss function into our 3-equation ISLM model. Again, it's the expected version of the loss function rather than just the loss function without expectations. We've still got those IS and those LM curves with those random white noise shocks. We've still got our targets of y star and pi star equal to 0. Once again, we're going to talk about people's expectations of the central bank before we go ahead and talk about solving it. Once again, we know that the central bank, or Bill, is pretty good at his job. He wants y and pi to be equal to 0 always. He knows that these random shocks are mean 0. The public knows these shocks are mean 0. So it's reasonable as the public to expect that y and pi tomorrow will be equal to 0. As we're thinking about the solution to that problem, remember that the central bank cannot respond to shocks that they don't see, or they cannot respond to shocks before they happen. They can make their best guess at trying to respond to the shocks, but they won't be able to perfectly match shocks that they can't see when they're setting the interest rate. Now we're once again going to start solving, so let's go ahead and simplify our loss function based on the other equations in the ISLM model. So again, I put in zeros here, and we can start going through and substitute y and pi. We're going to get down to this loss function right here, and that's the one that we are going to start taking the derivative of. But notice that I can't take the derivative of the expectation, so I'm going to have to simplify that first using that rule that we saw earlier. Now we're going to use that rule that I just talked about, so all I'm going to do is make that substitution right here, and then I am going to get to this loss function right here. Feel free to pause if you would like to look at the math, but otherwise we're just going to keep going into taking the derivative of this loss function and finding the ideal r star t. So I am just going to set this up, take the derivative. Notice that everything's going to cancel and we're going to get rt squared equals 0. Now the thing to note about expectations is we haven't actually said the central bank should be setting the real interest rate equal to 0. Because we're dealing with expectations, this is really the interest rate gap. This is the difference between the real interest rate today and what is considered the target or the ideal interest rate. How do you think about the fact that the real interest rate gap is equal to 0? Like, what does that mean? Well, this means that rather than try and get ahead of shocks that you see in the IS or the LM curve today, you should only respond to shocks you've seen. So yesterday you made the real interest rate, but you weren't able to see the shocks that happened yesterday. But then you wake up in the morning today and you could see those shocks, but you haven't been able to respond to them yet. So you should respond to those shocks. You should not try and get ahead of whatever you think might happen shock-wise today. So if based on yesterday's shocks, you think the real interest rate should maybe be like 2, but you're worried there might be a really high positive demand shock. So you're like, well, maybe I set the interest rate up to 3 to sort of get ahead of what I think might happen. This answer tells you, no, you shouldn't do that. You should only respond to the shocks you see. So the central bank should only respond to those observed shocks, not shocks they expect, and they should fully respond to what they see IS-wise or demand-wise, and they should only partially respond to the shocks that they've seen yesterday towards inflation. And again, if they're doing it right, people should expect that the output gap and the inflation gap tomorrow should still be 0. Let's start again by thinking about output and the expected value of output tomorrow. So if I have my IS curve and I fully respond, this is the 0 gap. Notice that again, the output gap today is just going to be the demand shock because I haven't been able to respond to that, and I'm not trying to respond to that because I don't know exactly what this shock is until it happens. Now if I take the expected value of this output gap for tomorrow, notice it's just going to be today's expected value of the demand shock shock tomorrow, which is 0, so it's reasonable for people to expect that tomorrow the output gap will still be 0. Moving on to inflation, same thing. Notice here that our inflation today is just going to be both the demand shock times its value k and the inflation shock, because the central bank again can't correct for things that they haven't seen yet. They're only correcting for the shocks that they saw yesterday but weren't able to respond to yesterday. Again, I can take the expected value today of inflation tomorrow. That's just going to be a linear combination of the expected value of these mean zero shocks. So again, completely reasonable for people to expect that the inflation gap tomorrow will also be 0. So hopefully this gives you a better idea of how to solve unobserved shocks and what it means for the central bank loss function and behavior. If it was helpful, make sure to like and subscribe, and we'll see you next time for another case of econ struggles.